the hypothesis test for matched pairs. It says to find the test statistic, the differences in each of the pairs are used to calculate the mean difference and the standard deviation of differences. So we're looking at differences still. We did that before as well with the independent groups, but we're doing it differently. We're going to see how that plays out in our example in a moment. You notice that only the t-score applies. We're always going to be using a sample standard deviation. And we see the formula for how to calculate the test statistic right there. So again, it's a t-score, right? And notice that, as compared to the original t-score, x bar minus mu over s over the square root of n, now we have x bar sub d minus mu sub d over s sub d over the square root of n. That d stands for that it represents the average for the differences, right? The sample mean of the differences, the population mean of the differences, and the standard deviation of the differences. What's that all about? Let's dive into practice problem number 5. It says a college athletic trainer believes by taking a special vitamin, weightlifters can increase strength. That sounds suspicious, but okay. 8 athletes are randomly selected and given a test of strength using the standard bench press. I'm guessing most of you guys are familiar with the bench press. You see guys doing it and ladies doing it in the gym, right? It's where you lay down on a bench and you got this big barbell suspended over you, and they stack up the big weight plates on the side, right? And your buddies help you out and see how much you can lift just using your arms and your chest. So there you go. There's the bench press. All right, so that's how they're going to gauge whether people get stronger or not after using this vitamin. After 2 weeks of supplementation with the vitamin, the athletes are tested again. Okay, so they test them before they start taking the vitamin, then they take it for 2 weeks, and then they test them again. And you can see the results there in the table. So there are 8 athletes, and the second row, we are thinking of group 1 as before they took this supplement, and we see all of their numbers there, how much they were able to bench press. So that is some, I'll just tell you, if that's in pounds, that is some weight. These people are pretty strong. And then the next row, we're thinking of group 2 as being after they've been taking the supplement. So the idea is hopefully they got stronger, which looks to be the case for the first two people there. First 2 athletes got stronger. The third athlete stayed the same, able to bench press 180. The fourth athlete, you notice his numbers or her numbers actually went down for whatever reason. And then the 5th athlete went back up. The 6th athlete went down as well. The 7th went up, and the 8th stayed the same. So it's not so much the numbers that we care about, it's the differences between them. How much stronger did they get, or did they stay the same, or did they actually even lose some strength for some reason? Okay, we are going to test the claim that the vitamin will increase strength at alpha equals 0.05. All right, let's begin with the null and alternative hypotheses. So step number 1, the null hypothesis. Well, that might look familiar. We assume that the difference between them is 0. The alternative, let's think about this. Mu1 minus mu2. How's this going to work? You know what? I realized something. I made a mistake here. It shouldn't be mu1 minus mu2. I apologize. It should be mu d equals 0, and mu d something, some symbol 0. Probably effectively we would have known what to do later in the problem anyway, but we want to be accurate here. Okay, so my mistake. The null hypothesis, mu d, the difference, the average difference, we're going to assume to be 0. We're going to assume that this supplement does not increase your strength. It doesn't take away strength, but it doesn't increase anything. So the difference from one test to the next is 0. What symbol would we use for the alternative hypothesis? And now it's really easy to get this one wrong. Okay. We're thinking that it's going to increase their strength, right? So if it increases their strength, then do we want to say it's greater than 0 or less than 0? Be very careful here. We actually want to say it's less than 0. You're like, what? I thought it was increasing strength. So increasing means greater than. That's true, but remember, we're thinking of group 1 as before they took the supplement and group 2 as after they took the supplement. So when we subtract, if they got stronger, we should actually get a negative number when we do first group minus second group. We want to see negative numbers here. Now you could easily reverse this and call group 1 the after and group 2 the before, and then you would want a positive number. And maybe that makes more sense to you to do it, but that's not the way the problem set it up. They're calling group 1 the before and group 2 after, so we always subtract group 1 minus group 2. So if they do get stronger, we need those values to be negative. Okay. That was a bit weird. And I made a mistake in setting it up originally, so that doesn't help. Okay. Well, we got it correct now. Let's move on to calculating the test statistic. And here's where we're going to use that t-score, and we're going to realize why we need just a t-score as we do this. To calculate the test statistic, okay, so I've got the formula there. We're going to begin. We've got a little bit of work to do before we can just plug in these numbers, it turns out. We need to first calculate all of the differences. We need to go through each of the 8 athletes and do the before minus the after. Okay, so that will take just a moment and some space. So let's start with the difference for the first athlete. So D1, the difference for athlete number 1, 210 minus 220. He got stronger, so he winds up with a negative 10. And I'll just show you all of my numbers here. No reason to go through them one at a time. Athlete number 2, D2, 230 to 235. When we subtract, he also got stronger, so negative 5. Number 3, well, his numbers were the same, right? 180 minus 180, so his difference was 0. D4, he actually lost 5 pounds on his bench press, so he ends up with positive 5. D5, now this guy or lady, whoever it is, we don't know, got 10 pounds stronger in the bench press, so negative 10. And as we look through the rest, positive 5 for number 6. Oh, do I have these backwards? D6 should actually be, oh yeah, positive 5 because they got weaker, and then negative 5 for D7, and then 0 for D8. Oh, confusing myself here too much in this problem. So we have all 8 differences. Now here's what we're going to do. We're going to type these 8 numbers into a column in StatCrunch. Negative 10, negative 5, 0, 5, negative 10, 5, negative 5, and 0. Put that all in as a column in StatCrunch and have StatCrunch calculate the mean and the sample standard deviation. Now, it'd be a lot easier if we were in class together and we could walk through it and I could show you exactly what I'm clicking on, but we've done this before. Enter those numbers as a column, right? Start with that. Then go to Stat and Summary Stats, and then Column, and you can find the mean. You'll find it to be negative 2.5. So that is the mean of the differences. So that's x bar sub d is negative 2.5. And you'll find the standard deviation of the differences. It's a sample standard deviation. So S sub d, the standard deviation of the differences, turns out to be 5.9761. Make sure you can recreate these same numbers yourself. Okay, so we're going to take these, and that's what we're going to plug in into our formula. Then we'll know what n is already, right? N is 8 because there are 8 athletes. And what do we do for mu sub d? Well, of course, we assumed that to be 0. One thing else, just before we go on, to point out here, notice the difference between the matched pairs and the independent groups. You know what, I guess I never really pointed out why this example is a matched pairs. Maybe you saw it yourself, but these are the same athletes, right? We take the same person before and after, so there's this natural pairing between the two groups, because it turns out we don't actually care how much they could bench press coming in. We just want to see if they got stronger. And so there's this nice pairing we have, and we can just look at the differences. Turns out the matched pairs style is a better hypothesis test than the independent groups. Why is that? Because when we take the differences between each, we can see, okay, this individual became this other individual, right? It's the same person. So all of the bias that would go into who they were in the first place also comes out in who they were later. So it's like it cancels out. And we're able to eliminate so much bias because we're doing a matched pairs. We just want to know, did they get stronger? Doesn't matter what you were at before, right? And so you might even think that like an independent groups is a better sample, but actually it's the matched pairs because we see the one-to-one, difference before and after in this case. Okay, so what we're doing is we are finding the differences first, and then from those differences computing the sample mean and the sample standard deviation. Before, we couldn't do that. We had to take the sample mean of one group and the sample mean of another group and subtract them. So we took the sample means first and then subtracted the sample means, right? But in this case, we can find the differences first and then take the average of the differences. That is a more accurate way to go about it. We're just, you can't do it in the other style because there's not that natural pairing. All that to say, the matched pairs, definitely a more reliable way to test a product. So you see a lot of products doing that. Try our soda, try the competitor soda first, then try ours. Which one do you like better? Well, it's the same person, so they really get a good result. Okay, anyway, let's move on and calculate our test statistic. We know the formula, and so we're going to plug in x bar sub d, the sample average for the differences. We assume that mu sub d is 0, so minus 0. There's our sample standard deviation of the differences divided by the square root of the sample size, 8. Okay. We notice that we need it to be a t-score because we're doing a sample standard deviation. And typically in these matched pairs examples, you have a low sample size. You can get away with that because you know that you're going to use a t-score anyway. Okay, putting all those in, make sure you can compute negative 1.18 as your t-score. Okay, from there, we go on to step number 3, finding the p-value. How do we do this? Well, we know it's the t calculator we're going to use. The degrees of freedom, well, we only have the one sample. The sample size is 8. So there's nothing unusual about the degrees of freedom here. It's just one less than 8. In other words, 7. So, all right, so we've got the t calculator. Our t-score came out to be negative 1.18. So do we use a less than, a greater than? Well, right, our alternative hypothesis was a less than. We have a negative here as well, so that's going to tell us to use a less than. Okay. Putting that all into StatCrunch, you will find this p-value is 0.1383. All right. Well, let's compare that to alpha. Clearly, the p-value is bigger than the alpha. Oh, you know what? There's some evidence, but it's just not enough. We got a fairly low p-value, but not small enough to be convincing. So we fail to reject the null hypothesis. And let me go ahead and give you the interpretation as well. There is not enough evidence that this vitamin will increase strength is one way you could say it. There's not enough evidence to show that it's statistically significant. Now, that said, that's fairly small, right? I mean, that's, you know, if you said, hey, do I want to take this vitamin, see if I can get stronger? Why not? I'd try it out, Maybe you'll be that person who raised their bench press by 10 pounds, Who knows why these people lost some pound. Anyway, okay. It's not, it hasn't been shown to be statistically significant, but, it's getting there. It's getting there. Okay, let's stop this video here. Oh, you know what? Actually, before I wrap it up, let me just mention, we don't have an example, but let me mention the confidence interval for matched pairs. It says the point estimate is x bar sub d, and the margin of error formula is there. The confidence interval for the matched pairs is going to be almost identical to the confidence intervals we did back in Chapter 8. Although this time, again, remember to take all of the differences first, right? Find these two numbers in StatCrunch, and then there's your formula. Margin of error equals the t-score, depending on what your confidence level is, times the sample standard deviation of the differences divided by the square root of the sample size. And then the confidence interval itself is your x bar sub d minus the margin of error and x bar sub d plus the margin of error. We don't have an example to do together just because it's so similar to the way we did in Chapter 8. But you will see at least one like that in the homework to get some practice. Okay, now we will stop this video. We've got the proportion based coming up next.